Thank you, Paulo, and thanks everyone for some fantastic presentations so far today. I'm learning a lot. This is awesome. So it's always fun to try to figure out how to share a screen, and I think we have success. Okay. So about me, I'm a Strimzi user for a very long time, since 2020. In fact, right after I came out of college. I've been using Strimzi for, and this is the third company I've been using Strimzi. So I'm a huge fan of the project. And in fact, the first time I was exposed to Kafka at all was using Strimzi when I was working on the Kubernetes team at another company. And a couple of years ago, I founded LittleHorse Enterprises, and we provide a integration and automation platform. And there's many components to it. The core of it is an open source workflow engine. We, of course, use Strimzi to power our Kafka clusters in our cloud product, and also in many cases, we use Strimzi in on-premise installations as well. Because I was born into Kubernetes, I literally started learning Kubernetes about 6 months after I learned how to code. I like using YAML a lot more than I like using the Kafka command line scripts. Also, I didn't learn in Java. I learned in Python and Go. I think that might hurt my father if he heard me say that. But because of that, I was always afraid of trying to use the Kafka admin command line clients, because I didn't even have Java installed on my machine. So it was fantastic being able to use Strimzi early on in my Kafka career. So without further ado, what are we going to talk about today? Today, I'd like to shed some light on some local development tricks that we use inside LittleHorse, because I'm CEO. I don't have as much time to write code as I used to, but I do like to test things, which means I don't want to have to spin up an entire AWS environment every time I want to test our platform. So I like to make sure that everything runs locally. And today, I'm going to walk you through a story, which is when one of our team members developed a Kafka connector for LittleHorse. How did I test this? How did I go about testing it and running it locally? And it turns out you can actually learn quite a bit by going through this story. So what we want to do today is make it so that I can go to my terminal and produce records to Kafka. And then our Kafka connector can consume those records and run workflows in LittleHorse. And we'll see if it works. We're going to do a live demo. I only have a Kind cluster and a Kafka cluster created. We're going to deploy this and set up ingress and networking, and then live try to do it. We'll see if it works. And there's two problems that are difficult. First is Kafka Connect plugins, and the second is getting external access to the Kafka cluster. So hopefully we'll learn some concepts about how Kubernetes networking works, how the Kafka client bootstrap protocol works, and how Strimzi's Canico build feature works in Kafka Connect along the way. So the plan for how to solve this is we're going to use Kubernetes and Docker, otherwise known as Kind. And of course, we're using Strimzi to deploy Kafka. And we're going to run Kafka Connect and install the LittleHorse Kafka Connector plugins. We're going to publish messages to Kafka from a terminal. And we're hopefully going to have the LittleHorse Kafka Connector read those messages and run a workflow in LittleHorse. Everything's going to be open source. And there's the code for this, the GitHub repository, including the LittleHorse workflow, all the YAMLs to deploy everything, a script that creates the Kind cluster. Everything is on my GitHub. There's a link to it at the end of the presentation, and I'll put it in the Strimzi Slack channel as well. So what is Kind? Kind is a very, very useful tool that we use extensively at LittleHorse, and I think many other places use it as well. It's Kubernetes in Docker. So it's an alternative to Minikube, or I think Docker Desktop, which is a paid product, has a Kubernetes plugin as well. And it's really flexible. And in fact, it was originally developed, I believe, as a tool for the developers of Kubernetes to have local setup for the Kubernetes development itself. And what Kind does is it runs Kubernetes inside Docker, where every Kubernetes node is just a Docker container. And that makes it incredibly flexible. And it's also useful for certain things like injecting network latency between Kubernetes nodes so that you can test more production-like settings on your own laptop. One thing that we do at LittleHorse quite often is we'll deploy a 3-node Kubernetes cluster and deploy LittleHorse across all 3 of those nodes and kill one of the Docker containers and ensure that we can survive the simulated outage of an entire availability zone. But what we're going to do today to take advantage of Kubernetes and Docker is we're only using 1 node because It's not the point of the demo, but what we're going to do is we're going to take advantage of the very flexible port mapping that you can get with Kind so that we can actually access Kafka from outside the cluster. Another side note is that Kind is very friendly to running tests in pipelines. And we're working on this for our own Kubernetes operator that we use to run LittleHorse. It's very, very cool. So let's get right into it. The first challenge, as we said earlier, is that we need to run Kafka Connect, but also Kafka Connect needs to download the LittleHorse Kafka Connect plugin. So every Kafka connector is just a jar file that is loaded at runtime. It's a class that implements or extends the Kafka sync connector or Kafka source connector class, which means that the Kafka Connect workers or the Kafka Connect clusters need to have access to those jar files on disk. And Strimzi doesn't ship with all 10,000 open source, maybe not 10,000, all 100 open source Kafka connectors embedded, because that image would be hundreds of gigabytes. So there's a very useful feature in Strimzi that uses Canico to securely build a Docker image inside the Kubernetes cluster and the build process will download all the plugins that you want. So here's a screenshot from the Strimzi documentation. It's the Kafka Connect CRD. And this Kafka connector CRD allows you to specify certain plugins that you download. So for example, you can download a TGZ file, you can download jars from Maven Central, and you can download jars from some URL. There's also a Maven plugin option. And what happens is if you deploy a Kafka Connect cluster like this, Strimzi will create a Canico job, a pod that runs with Canico, and it will pull all the plugins, create a new image, and then when that image has been built, Strimzi will deploy the Kafka Connect cluster from that image. And a couple days ago, Jakob Schultz merged a really, really, really cool PR to Strimzi, which will take advantage of the new Kubernetes feature called image volumes, where you can mount a Docker image as a volume on a pod. And this will probably be another really, really cool way to install plugins in Kafka Connect, but it's only going to be available in Kubernetes 1.34 and Strimzi 47, both of which, well, 1.34 is available, but Strimzi 47 is not yet available. So until a couple months from now when that's released, this is, I think, the best way to build Docker images with Kafka Connect plugins. So let me talk about the first first attempt to solve this problem. The problem being that the Canico worker needs to build an image and push it to a Docker registry, and then the Strimzi operator deploys Kafka Connect using that image. So we need access to an image registry, and because of local dev, I didn't want to have to, depend on a remote, Docker hub or some other form of image registry. So the first thing I tried to do was deploy the Docker registry pod as a pod in the Kind cluster. When I did that, Canico was able to push an image into that pod, and the build succeeded. But when Kind tried to deploy the Kafka Connect pod, it couldn't. The Kind node didn't know how to pull the image from this image registry. So the deployment failed, which brings me to the second attempt that we did. What we did was decide to take advantage of some really cool Docker networking and the fact that Kind is just a Docker container. And we deployed a sibling Docker container. Docker registry runs as kind of like a brother or a sibling to the Kind node. And we used Docker network link so that we could somehow make the Docker registry accessible on the same hostname to both the Canico job and also the Kind node itself, which is the actual Kubernetes node or just another Docker container in our Docker environment. So with this, we were able to have the Canico job push the image to the Docker registry successfully, just like we did in the past, but also the Kind node is able to pull the image and use it to deploy the Connect worker. So at this point, it's time to do a live demo, and this is always exciting. So we're going to take a look at some code that we're going to deploy. So I will make this a little bit bigger. We can see we have a Kafka cluster running in Craft, and I know Tina just gave a presentation saying that we should not have brokers and controllers on the same node in production, but this is a local dev demo, so I am using mixed mode. All three of these Kafka servers have both the broker and controller or node. And I have LittleHorse deployed, of course. The LittleHorse dashboard is deployed as well. Here's the Strimzi operator. So what we're going to do is we're going to deploy a Kafka Connect cluster and deploy a Kafka connector. So first, I create a Kafka user because I have secured my Kafka cluster, and the Kafka Connect cluster will use that Kafka user to talk to Kafka. You can see here's where I configure the authentication, but importantly, what I'm going to do is use the Strimzi Kaneko build feature in order to download the LittleHorse Kafka connector, which we'll use at the end for the final demo. You can see it's just a zip file hosted on GitHub. And these are some options that we had to add to the Kaneko build to get it to work on localhost. So let me show you quickly the output of Docker PS. We can see here that this is my kind node, the Kubernetes cluster. And as a sibling, I have the Docker image registry deployed locally. So let's apply this YAML and see if it works. So we can see now that the Strimzi Kaneko build image has started, and we'll look at the logs for a little bit. And while it's running, we can see that it's now downloading the file, and this will take a while because I'm sharing my screen and everything. So I'm going to go back to the presentation, and hopefully this will work, and we'll be able to run the Kafka connector later. But we're about to run into another problem, which is so far we have gotten Kafka Connect deployed, but now we have to figure out how to produce records to Kafka from outside the cluster. So while my laptop is, about to explode because of all the things it's doing right now, let's go back to the PowerPoint. Kafka and Ingress don't really get along very well. Ingress being the classic Kubernetes API. So Ingress was originally built for HTTP1 traffic. It doesn't really understand the Kafka protocol. In fact, it doesn't understand the Kafka protocol at all. And another problem with Kafka Ingress is that standard service routing generally assumes that all endpoints in a service are the same. And Kafka, as we'll see very soon, does not treat all brokers the same. All brokers are special, and they all have different roles and different responsibilities regarding what partitions they're the leader of. And Kafka's Bootstrap protocol is based on TCP, and it's not at all related to HTTP, and it relies on being able to address brokers individually. So let's take a quick, break from Strimzi and dive into Apache Kafka's client Bootstrap protocol. So as we know, Kafka is a distributed system, and topics are broken up into partitions. Partitions can live on, every partition lives on a broker, and a topic can have partitions on many different brokers. So that basically means that the Kafka client, if he's going to produce or consume from a specific partition, needs to know about what partitions live on what broker, which is where the whole concept of a Bootstrap protocol came about. So when a Kafka client wants to start doing something like producing or consuming records, it first asks any broker in the cluster to please let me bootstrap the Kafka cluster. So the first thing that happens is, that sends a bootstrap request. Then any broker who answers the request will send back some information about all the other brokers and perhaps info about what partitions live on what broker, so on and so forth. That's a little bit too deep for the level of this talk, but we get back some host names, for example. And then what the Kafka client does is the Kafka client will connect to all of the brokers that were returned so that it can produce and consume from specific partitions. And as you can see here, the standard Kubernetes ingress and service, which is built basically for stateless microservices and web backends, doesn't really fit this model. There are ways to get ingress to work with Kafka, and it's a little bit tricky. You have to have pass-through TLS so that the ingress controller is unable to inspect and reroute or change the traffic. And every broker needs its own host name. Jakob Schultz wrote another fantastic blog series about it. I put a link in the end of the description about how to get ingress to work with Kafka. And in fact, Strimzi has native support for it, but you do have to set up your ingress controller in a fancy way. So at LittleHorse, we use Envoy Gateway, which is an implementation of the Gateway API. The Gateway API is, I think a couple days ago, was just graduated into the standard channel of Kubernetes, which is exciting news. meaning that the APIs are now stable and can be built upon safely. The Gateway API is kind of a rethinking of how Ingress works in Kubernetes. So the Ingress API is not deprecated, but it is frozen. They're not adding any new features to the old Ingress API. But the Gateway API has many resources that are, for example, HTTP route, TCP route, TLS route, gRPC route that understand different protocols. So for accessing Kafka, what we use at LittleHorse is we use Envoy Gateway as the implementation of the Gateway API, and we use TLS routes, which is basically pass-through encryption. So we have end-to-end encrypted traffic from the Kafka clients to the Kafka brokers. And the TLS route is kind of like the equivalent of Ingress here. So the Kafka brokers will be terminating the TLS encryption, and it's everything goes through Envoy. Envoy doesn't actually inspect the traffic. There's other ways where perhaps you could write a filter that understands the Kafka protocol, but we haven't necessarily needed to do that in Envoy at this point. So there's a couple things that are important here. As we said earlier, every Kafka broker needs to be able to be addressed individually. And as you recall, let me check the time here. Okay, we're doing fine. As you recall, the kind node or the kind cluster is just a Docker container running on localhost, right? So all three of these Kafka brokers can't be localhost 9092. So one option is to have different ports for each of them. And another option, which is what we will go with today, is to use etc/hosts, which is a Linux. I hope it works on Mac. I don't really know. It's a Linux utility that allows you to rewire one host name to another. So what we're going to do is we're going to use a bunch of, Kafka Bootstrap, Kafka 0, Kafka 1, and Kafka 2 will all get rerouted to localhost, but they will preserve the host name. So then Envoy Gateway will be able to see, okay, this traffic is for Kafka 0, so it goes this broker. This traffic is for Kafka 1, and that traffic is for Kafka 2. And that little piece of magic will let us solve the problem of every broker needs to be individually addressable. And the second little bit of magic that we have to do is, if we go back to this picture, we need to, the Kafka clients, which are basically me in my terminal, is not able to directly talk to the Envoy Gateway gateway controller. The Envoy Gateway controller is just a pod running inside my kind cluster, right? It's not actually accessible. So what we have to do is we have to configure Kubernetes services and node ports and so on and so forth so that we can actually talk to the Envoy Gateway. And in this demo, we've got a couple listeners. LittleHorse is listening on gRPC. I have a dashboard listening on HTTP, and then Kafka is listening on the TCP TLS protocol. So we do a little bit of magic, and in fact, I also wrote a blog on the Strimzi website to discuss how this works. But one second. Yeah. So the way we did it is we deployed Envoy Gateway as a node port service in kind, and I'll show you the YAML file, relatively quickly. And what we can do is take advantage of the fact that a port on the Docker container is a node port on the Kubernetes node. So what we did was we mapped localhost port 80 to, for example, the node port 30,080 on the kind node. And then we created an Envoy Gateway node port service that listens on port 30,080 and routes it back to port 80. So effectively, localhost port 80 maps all the way to Envoy Gateway port 80 as well. Envoy Gateway's gateway listener on port 80. And we did the same thing for localhost 9092 and Envoy Gateway listener 9092. And you can imagine that's the one we're using for Kafka. So at this point, we have solved both of the problems that we've had with, number one, getting Kafka to build, or Kafka Connect to build, and number two, figuring out how we're going to be able to access Kafka from the command line. So I think it's time for a demo, and we'll get to see, actually, I haven't actually checked. We'll see if this worked. It looks like the build succeeded. We have the Kafka Connect pod is up, and hopefully the Kafka connector is up too. Yes, we have the LittleHorse workflow run connector, workflow run sync connector. It is successfully deployed. So that means the first part of the live demo has worked. Very exciting. So what we're going to do now is we'll go back to the LittleHorse dashboard, and we're going to run this workflow using Kafka Connect. What we're going to do is we're going to produce records to a Kafka topic representing customers arriving at a hotel. via, perhaps you could imagine that there's some geolocation on the mobile app in the phone that alerts something. And then our fictitious hotel management workflow is going to fetch information about the customer. And if they're a Platinum loyalty member, we'll send them a special welcome and prepare the room. Otherwise, we'll just go straight ahead and process their arrival. So I'm going to cheat a little bit and use a script to set up a Kafka producer from my terminal, and we're going to run the workflow a couple times. Anakin and Obi-Wan. Okay, so hopefully we should be able to go to the LittleHorse dashboard and see these workflows. So let's find Anakin's workflow. Okay, so this one's Anakin, the one that was just ran, and it turns out that Anakin is not a Platinum member. Oh, that's funny. It may be because he's not a Jedi Master. And we'll find Obi-Wan. Okay, so and it turns out that Obi-Wan is a Platinum member. I think the task worker that fetches a customer and determines whether or not the customer is a Platinum member is probably determining whether the Jedi is a master or not. So side note about me, I think Strimzi is actually the only open source repo I have ever committed to that does not have a Star Wars reference in it. And I will say that Kafka has one because I made sure to put it there, but it's just in the comments of the code. So with that, I think we finished a little bit early. We can take some questions.
Thank you very much, Colt. So it was really interesting about how to use in-kind and how to interact with Strimzi on kind. I can't see actually any question. There was just a comment about the TCT host on Mac seems to work.
Oh, it does.
Yeah, well, you were talking about setting up etc hosts on your laptop, so it seems to work on Mac. I also don't use Mac, so I didn't know. I can't see any questions. So if there are no questions, I think that, yeah, again, thank you very much. If people will have any questions, as I already mentioned, Colt will be available anyway on the Strimzi Slack channel in the CNCF workspace to engage with him.